Welcome to another episode of my construction videos. What I do on this channel is to create construction content, that's construction knowledge and education for people that actually need the knowledge, and I do it in a way that is very simple for a layman to understand what we do in construction. So if I'm doing anything, I always do it as if we are doing the practical, very easy for people who are just watching a layman who is out there and want to know more information about construction, and for engineers on site, probably upcoming engineer or engineer on site that want to know more about the work, or even though it is a client that want to know more about construction. So I do this video. What I do here is just construction video for them to know more about construction. And in my last video, I did a video on knowing the quantity of water you need for a concrete job. And this video, just like I said in the last video, that in my next video, I'm going to do a video on how to know the quantity of sand, cement, and granite required for a job. So in this video, I'm going to be taking you through the process of how to know the quantity of your binder, that is the cement, the quantity of your final grade, which is a sand, and the quantity of your coarse aggregate that you need in a job. So at the end of this video, if you find the video interesting, you can give me a thumb up at the end of the video and probably subscribe to my channel, and you can click on the notification button so that you'll be one of the people that will be notified whenever I upload something useful. So join me in the video and let's begin. So just like I said in the introductory part, that what we'll be doing today is to know the quantity of cement, sand, and granite required for a job. So in this video, we are going to be doing the calculation just as if we are doing it on site. So let's go to the content of today's video. So in the content, I have mix ratio, quantification, calculation, and a table showing mix ratio and materials needed. So in this video, I'm going to be taking you through these four content. So these four content will give us what we need in calculating the quantity of material we need for our job. So let's go to the first content, which is the mix ratio. So just like I've said in the previous video, that mix ratio, when people see us on site, when they see site engineer, project manager, their mind is, well, what we do on site, we just mix any ratio to get what we do, and probably in plastering job, in a concrete job, and any other. No, that's not what we do. Everything we do on site has quantification, like the shocking we do, the plastering, the cement, and the sharp sand we use. They have the quantity we need to use. They have a measurement. In concrete as well, it has a measure. We don't just pour any amount of cement we have, or any amount of sand, or any amount of granite for the job. No, there is a particular mix ratio in which you need to adhere to in order to get a specific strength that you want. So I have it as a note here that concrete mix ratio refers to the proportioning of concrete constituent in a specific proportion. This can be done by volume or by weight. So when you proportion them in a specific proportion or in a specific ratio, that is what we mean by mix ratio in concrete. And before we can do our calculation, the reason why I'm bringing this note on mix ratio is because we need to know our mix ratio, and we need to know the quantification of what we are doing before we can do our calculation. So I give different mix ratios with their grades, with their grade. Yeah, that is their grading, that is their compressive strength after 28 days. So we cure concrete for 28 days, and after 28 days it will attain its maximum strength. So there is a mix ratio of 148. 148 meaning one part of the cement, that is the binder, to 4 part of the sand, and to 8 part of the granite. What do I mean by that? We measure this in ekpan. So half bag of cement is one ekpan is half bag of cement. So you just divide your cement into two. Half of it is what we got to as one, yeah. Then 4 ekpan of sand is what we got to have four. 8 ekpan of granite is what we refer to as eight. Now, if you miss this in this proportion, if you mix it together with the adequate water content, at the end of 28 days after curing, we are going to have this mix ratio or more. So, and this, if you miss 148, it is used, it is a weak concrete. That's, I label it as a weak concrete. That is, if you are, probably you want to do a walkway, so that's when you need this kind of concrete. It's very weak for weak job. You can miss and make your mix ratio 136. At the end of 28, is going to give you 10 newton per millimeter square. That's a compressive strength, and that is for mass concrete. That you can use it for job that is not when you don't need too much strength. Understand? Too much strength. Now the next one is 124, which is grade 15. We call it grade 15. So it is 124. That is the minimum you can have for your reinforced concrete job. Now, if you are doing a job that involve the embedment of reinforcement, i.e., the reinforcement inside a concrete, where you need to strengthen the concrete. Now, that's when you use 124. There's 124, we call it grade 15 also. So at the end of 28, it's going to give you grade 15. So we also have 1.5, 3, which is grade 20. We also have 112 and many more. You can have 0.75 and 1.5. You can have 0.51, depending on how strong you want your concrete to be. Now, the reason why I'm sharing this idea of mix ratio is because we need to know our mix ratio before we can do the quantification for the amount of sand, granite, and cement we need for our work. The next slide shows the quantification. Now, we also need to know this quantification of the amount, that's the amount of job we want to do before we can calculate what we need to do. So that's why I shared an experience of mix ratio. We need to know our mix ratio. You need to know the quantity of what you want to do before we can calculate the amount of material we need for the job. So I said on quantification, this refers to the multiplication of given value to obtain the volume of concrete required. That's like I've said. Concrete is calculated in volume, therefore the work to be done must be quantified in volume before calculating to get the material needed. So if you are working, if you want to get the number of material needed in a concrete job, what you need to do is to sum up your value, multiply them, and get your value in volume. That is when we can now convert the volume to the numbers of material we need. So, and I gave some instance, I give a formula here that the quantity will be length multiplied by breadth multiplied by depth, which can be regarded to as the height. So I use this example here. Let's say you want to use this as an example. So let's say we have this box, you want to cast this box here with concrete. So how do we get the volume? It is just the length, which is this, multiplied by the breadth, which is then multiplied by the depth. And when we do that, we are going to have this value here in meter cube, or we convert to in millimeter cube rather, or we convert to meter cube. Similar thing to this here. So we have this plate here. Let's say it's a plate. We want to fill it with concrete. So just multiply. Here I use 3.6. I use this value 3.6 meters. Here we have the unit in meter. Here we have in millimeter. So 3.6 multiplied by 2.5 by 0.2, and I will have this value. So if you want to convert from millimeter to meter, it just from your millimeter to meter is divided by 1000. That is 1000 millimeter make 1 meter. So if you are converting a millimeter cube to volume, you just divide by 1000 in 3 places. So that's how it comes. So this is just a note on the quantification. I've given a note and a summary on the mix ratio, which we need to know before getting to our calculation. I've also talked on the quantification. Now let's go to the actual calculation. Now I have the calculation here, and I said, okay, now that we know the mix ratio and the quantification, so let's now assume that the mix ratio we want to use is 124, and the quantity we want to do is 1 meter cube. So that is what we have here. We want to do the quantity is 1 meter cube and the mix ratio is 1 to 4. So what do we do first? What we do first, after getting the quantification, you multiply by 1.54. That 1.54 is a constant for you to get the dry volume of concrete, because your material, you'll be requesting for your material in dry volume, not in wet volume. So you just multiply 1.54 multiplied by the volume you need. It can be 1, it can be 10, it can be 100. So here I'm using 1 meter cube as an example. So if you multiply that, you are going to have 1.54. And when you have that value, you need to sum the mixed ratio together, which is 1:2 ratio 4. So you are going to sum that together and you are going to have 7. Now after that, what do? The quantification is equal to value required, that is value uh, of the aggregate we require over the total value multiplied by the volume. Now when we do this in the mathematical way, you are going to understand. Now, for cement, if you need for cement, this is what you are going to do. If you need the quantity of cement, which will be 1/7, that is the part that belong to cement, which is 1. Just like on this message that I said, this is for cement, this for sand, and this for granite. There is 1 over the total value, which is 7, then multiplied by the volume that we have here. If you do that, you are going to have 0.22 meter cube. If you do for sand, you're going to have 2/7. And instead of doing for sand, you can just have this value and multiply 2 by this value. And if you want to do for granite, you can just pick this value and multiply it by 4 here. Just pick that, or you go through the normal process, you are going to have this value. So in case you want to do your job, this is the quantity you need. So for this job here, you need 0.22 meter cube of cement, you need 0.44 meter cube of sand, and you need this granite. But in case in the place you are, you don't require a meter cube, there's a lot of places in Africa where we don't, if you want to buy, except you are buying in bigger quantity and the person you are buying from understand the quantification in volume, the person can easily convert to bags. So in case you have this in volume, you cannot go to people selling cement in this part of the world and tell them I want to buy a cement of 0.22 meter cube. They just be looking at you. Cannot tell them I want to buy granite of 0.88 meter cube. So what do you need to do? We need to convert this value to a number that people understand, which is why we have it here, conversion from meter cube to bag or kg for the cement. Now let's recall that density is equal to mass over volume. Now recall that the density of cement is 1440 kg per meter cube. Is a constant value. That's the density of cement everywhere in the world. It is 1440 kilogram per meter cube. Now when you insert the values you have into this formula, which is density, we have our density to be this. Mass, we don't know our mass, that's what we are looking for. Multiplied by volume, we know the volume of cement to be this. When we input that, we are going to have the mass of 316.8 kilogram. That is the mass we have for cement. Still yet, if you want to buy cement, you don't go to the vendor and tell them I want to buy cement of 316.8 kilogram, or let's say 320 kilogram. They will just be like, what is this one saying? So you need to convert that to number in bags, and that is divided by 50, because 316 kg, one bag of cement is 50 kg. So one bag of cement is 50, so just divide by the number of cement. And in case your own bag of cement is 20 kg, just divide by 20. You know the number you need in bag. So this is the number you need in bag. So for this work, I'm going to need, for this work 124 and the quantification is 1 meter cube, I'm going to need 6.4 bags of cement for the job. So that's, I'm going to, if I'm not adding any waste, let's assume I won't have any waste, I'll be having 6.4 bags of cement for the job. Now let's calculate, that is for cement. Let's calculate for sand. Now if I want to calculate for sand, all these still remain the same from the previous calculation we did. This is that of sand, so I need to do that of sand also. I need to convert from kilogram, from meter cube rather, to a value in kilogram or in tonnage, depending on how much the sand I'm going to be needing will be. So density is equal to mass over volume. Then the density of sand is 1602 kilogram per meter cube. That is a constant. Anywhere in the world, it is 1602. Now we need to input this into our formula. We know the volume of sand we need. So the mass for the sand that's defined agree will be 704.88 kilogram. Yeah, you can say 705 kilogram. When we convert that to ton, you're going to have 0.71 ton. So when you convert to ton, you will have 0.704. I decide to convert to the nearest two decimal place, that is 0.71 ton for sand. Now that is for sand. Let's go for a granite, just the same process. So we know this value as usual. So you can just convert from meter cube to tonnage or to kilogram. We have our density. Density of granite is 1602. However, some people use 1600 for the sand, for the density of sand and granite, but I prefer to use 1602 to cater from some waste as well. So 1602. And when you do your conversion, you are going to have 1409 kilogram. Let's say 1410 kilogram. Now, when you convert to ton, that is divided by 1000. So 1000 kilogram is equal to 1 ton. So when you convert, you are going to have 1.41 ton. So that's how to calculate for the amount of quantity you need. So I just did for 124 and I got 6.4 bag of cement, 0.7 ton of sand and 1.4 ton of granite using the mix ratio 124. So that's how to calculate for the material. Now I think I give okay, I have another calculation here. So for I have another calculation now, and here I use 136 for same 1 meter cube instead of 124. So just follow the same way. First thing you do, okay, I mean dry volume here, sorry. I'm supposed to have dry volume is 1.4 multiplied by the volume. You have this. Sum your mix ratio together, you're going to have this. Then for the part of cement, that is 1 over 10 multiplied by this, you're going to have this. You do for sand, you have this. You do for granite, you have this. And when you do your conversion now, you just multiply this 0.15 for multiply by the density of cement, you're going to have your value. Now if you multiply the density by the volume, you're going to have 4.5 bags. And for sand, this volume multiplied by intensity of sand, you're going to have 0.7 ton. And this, if you take a look at it from the previous one, you know that this cement reduce, but the quantity of the sand will increase or still remain the same, the quantity of the other aggregate, but the cement will be reducing if you are going down. I just move from 124 to 136, which is I'm going down the rank of the mix ratio. So that is how to go about the calculation. It's not difficult. It's not if you take your time, you are going to get it. So I have a table here, so I just did for everything that I cannot do in the video. Then I brought out calculation for 1 meter cube in case you want to know the quantity you need for 1 meter cube of your job. Let's say your job is 1 meter cube. So these are the quantity of cement, quantity of sand, and quantity of granite you need. So for 136, for 136 that I just did, so I have 4.4 bags. I have this quantity of sand and I have 1480 as the quantity of granite. For 134, although 134 is not a standard mix ratio, 136, those one are asterisk, are not a standard mix ratio, but there are sometimes we decide to put a small amount of sand to the job in order to get what you want. Probably you want a mix ratio that will not be too coarse, so you can decide to adopt some of this mix ratio. So if you are doing this, you have this quantity of cement and this quantity of sand. So these are the quantity you are going to have for all these mix ratio. 11, if you are doing 1 2, you have 11 bag in 1 meter cube. And in case probably what you want to do is not for 1 meter cube, let's say it's for 10 meter cube, you just multiply everything by 10. And in case what you are doing is just for 5 meter cube, just multiply this by 5, multiply this by 5 and this by 5, and you are going to have your value. So I did for 10 meter cube also, which is this. So I multiply the one of 1 meter cube by 5 and I have this. And in case your work is not up to 10 meter cube, is not up to 1 meter cube, and it's just one bag, what you want to miss is just 1 or 2 bag. So I did for bag also. So for the same mix ratio, if you are using one bag for, let's say you want to do 136 and you are using one bag, so this is the quantity of sand you will need, that is 165 kg. So I know people might be asking me, so how do you convert kg to hectare, because I said the measurement of the ratio is in hectare. So the excuse is just that hectare is not a standard measurement. It's not a standard measurement. I might decide to say 2 hectare, 3 hectare, and at the end, probably the hectare you will be using will be bigger than the one I'm using. So hectare come in different sizes. So it's not a standard measure because it comes in different sizes. Probably what you can do is to have a scale and measure this. I say batching is done by weight and by volume. So you can probably measure this from a scale and know the quantity you need. Uh, So that's it. You can just measure this and know the quantity you need. So that is that for that. So that is all in today's video. Through the video, I've been able to teach you how to calculate for the amount of sand, cement, and granite you need for your job. So if you found the video interesting, do well to give me a like button and subscribe to the channel. Then you can click on the notification button and you'll be one of the first people to be notified whenever I upload something useful. Thanks for watching.